My name is Andy Nosal, he, him, and my current position is an associate professor of biology at Point Loma Nazarene University. My main job is actually undergraduate biology teaching, so that's what I do most of the time. But I still do research in the summer with undergrads, and that's in the field of marine biology. And specifically, I study the movement patterns of sharks and rays. So I'm interested in why these animals do what they do and what are the conservation implications of those movement patterns. I think when I'm teaching, which is most of the time, the most rewarding part is just helping students make connections between the material that we're learning and their everyday lives, just so that they can see why what they're learning is so important. And seeing that connection being made, that's really rewarding for me. And I think when I'm doing research with students, one thing that's really rewarding is kind of reliving my excitement of doing things for the first time through my students. So going on a boat for the first time, catching a shark for the first time, I get to kind of relive those moments through them. Another really rewarding part of doing research, I think, is the moment when you first get the data back after working so hard, and there's that brief moment where you're the only person in the world who knows the answer to the question that you've set out to answer. Of course, until you publish it or start talking to your advisor about it, but there's that really cool moment where it's just kind of you and the data, and that's really rewarding too. Typical day depends a lot. So during the academic year when I'm teaching, a typical day looks like me giving a couple of lectures, maybe teaching a lab, holding office hours, meeting with students, answering a bunch of emails. So that's and preparing for classes, grading. So each day is a little different, but they usually have some combination of those things I just mentioned. During the summer, my typical day, it varies even more. So some days I may be in the field with students, we may be collecting data, we may be on the boat, we may be fishing, we may be catching bait. And honestly, I feel like that's what most people think of when they think of what marine biologists do every day. But even when we're doing research in the summer, I mean, most of our days are not in the field. Most of our days are on our computers, analyzing data, doing statistics, writing, applying for grants to get money to do the next project. And so, so we have many typical days where we're just on our laptops and analyzing data too. I grew up in New Jersey and going to the Jersey Shore during the summer, so I had exposure to the ocean ever since I was a kid. So I've always been interested in the ocean, and I think during most of high school, I even, was interested in marine biology and thinking I was going to go into that field. But I would say it wasn't until I was an undergrad and I got to study abroad in Australia for a semester. That really sort of sealed the deal. I had the opportunity to take a field class and do research on the Great Barrier Reef, and it was in Australia that I saw my first shark in the wild. And so I feel like those sorts of experiences just solidified my interest, and I knew from that moment that I wanted to do grad school in marine biology and hopefully get a job in this field someday. One piece of advice I would say is don't limit yourself to one particular field of marine science. Let's say you're interested in sharks. Don't limit yourself to only getting experience studying sharks or doing research in sharks as an undergrad. And one specific example I can give is that when I was an undergrad, I applied for some summer research experiences. They're called Research Experiences for Undergraduates, REUs, really wonderful programs. There was one I wanted to get in Florida where I would have had the opportunity to study sharks, and I thought, oh, it was perfect. I didn't get that one. but I got a great one at USC, University of Southern California in LA, and I got to study sea urchin larvae and genetics of these creatures. And what was the other thing we studied? Looking at survival of oyster larvae. Never would have thought I'd be studying that, but all the skills I learned there, even though it wasn't in the species that I was interested in, they translated really well later on. So that's one piece of advice. Like, there's very few opportunities in any particular, subfield of marine biology, and you shouldn't limit yourself early on. Whatever skills you're going to get, they're going to translate, they're going to be really valuable. Some other pieces of advice I would say, really look for opportunities to strengthen your math skills, including statistics and coding. I feel like those are some of the areas where I wish I was stronger and where I developed those skills more as an undergrad. They came later, I developed them as a grad student, but it really put me behind the curve compared to some of my peers. So what I would say is look for opportunities to take statistics classes, including advanced statistics classes. Look for opportunities to learn how to code. Get familiar using languages like R, Python, maybe MATLAB. But I would say if you had to pick one, maybe go with R. That's what many people use, at least in ecology. And if you can learn one language, you can usually learn other ones fairly easily too. So look for those opportunities. And I would say also look for opportunities to strengthen your writing skills. I think a lot of people are surprised by how much writing we do in science, whether it's writing papers for publication based on your research, or writing grant proposals, or writing articles that are just meant to translate your science to the general audiences who are not experts in your field. So we do a lot of writing, and I think if you can hone those skills, you'll be better off too.